All right. Welcome to the Seattle Code Crafters Meetup. Today we have Ted M. Young, who you might know as Jitter Ted. Um, he's a Java technical coach, a great speaker, an author. He's been in software for about 30 years and is a really amazing advocate of extreme programming practices. He loves to help those new people in the industry, as well as the experienced folk, increase their joy in coding by showing them how to make their code more testable. He loves to ensemble and TDD, refactoring, domain-driven design, all those really excellent practices that make us great developers. He also is the creator of Jitter Ted's TDD game, which many of us I know have played. If you haven't, you totally should. And he carries that with him everywhere. So if you ever run into him at a conference or something, I'm guessing that you'd be more than happy to sit down and show it to people.
Oh yeah.
Yeah. And today he's going to talk to us about refactoring tests. So take it away.
All right. Let's get the share screen. Should be able to see big, bold refactoring tests. So welcome to my TED Talk, as I always say. I can say that because that's my name. And there is no AI in this talk. So if you're looking for AI, you're in the wrong place. But it is going to have stuff about tests. Let me just bring up chat so I can see the chat. Okay. And so, as Paige mentioned, I'm a technical coach. I help teams. I do training. And what I do when I'm not doing that is, as some of you know, I do live coding on Twitch for 3 to 4 hours a day, 3 or 4 times a week, where I basically build real stuff on screen, make all the mistakes that even us experts make, learn stuff just like we all do. And one interesting thing, we always talk about speed of writing code these days. If you look at my videos and I've done some analysis, I don't spend that much time actually typing code. A lot of the time, especially yesterday, it was like, what should I do next? How should I do this? And so on. So ask questions as you need. You can type them in chat and I'll somewhat pay attention, or if I miss something, I'm sure Paige will point it out. But I reserve the right to defer the answer if I'm going to cover it later. But don't hesitate to ask your questions. So I've been doing Java for for over 30 years, which is pretty much as long as Java has existed in the general public. I'm going to use JUnit as examples, and of course, the best assertion library ever, AssertJ. And I'm not biased at all. I only contributed the big decimal support in there, but even so, it's still great. However, this isn't just for Java. Pretty much all of this, the techniques and specifics may vary from language to language, but basically the ideas apply to all of them. One of the things I like to think about when looking at tests, first of all, tests are code too, but we don't pay attention to them as much. And also we do need to treat them differently than code. And we'll look at that. But I always think about this idea of a ladder, and I couldn't draw a ladder, so I ended up with stairs. And so the first thing we'll look at is sort of structuring tests. And then we how do we structure tests so that they're readable, right? One of the most important things, I know when I go into a code base, I come onto a team or something, looking at some code, the first thing I look at is tests. They tell me how to use the code in a way that is actually supposedly working if the tests pass. Of course, if they don't, that's a different story. And so how we structure our tests for readability is key. And the way we can do that is we'll look at we can increase the readability by using better assertions, such as an assertion library, but also customizing them, as we'll see later. And there are abstractions that we want. Sometimes they're just hiding details that are unimportant, and sometimes we want to work at a higher level. And this is, I've been doing a lot with event sourcing. And so event sourcing is all about, given these events, when I execute this command, I expect these events to be emitted. And I've been thinking a lot about, high level DSLs for phrasing that. In fact, maybe not going so far as writing it in free text, because I like autocomplete. Autocomplete's been around forever, and it's great when it works. And so, really thinking about how can we express what we think the thing should do and how we're going to know it did it, right? Those, if you've ever played my TDD game, those are the first two tiles on the game is like, what should it do? And how are you going to know it did it? And that's what tests tell us. So this is kind of a sequence of like, not all tests will reach the heights of test builders. Some stuff doesn't require it. Some stuff does, and we'll take a look at that. Custom assertions, that's where we start getting to more that DSL, that domain friendly kind of thing. And so, when we think about our tests, like what makes a good test suite? And so there's lots of variety of folks who've written on this. But basically it's a safety net. Right, we can look at it that way, and especially we need lots of safety nets these days. I won't say why, but we do. But it also has. I think this one is underappreciated, or perhaps not sort of in front of mind as much. Is it has to support refactoring. I know I've seen folks talk about TDDs like, oh gosh, I wrote these great tests, but then they're really brittle. Whenever I refactor, I have to change a bunch of stuff. Yes, but there are ways, some of which learn through painful trial and error, to better support refactoring. We'll look at some of those. Matthew asks where the talk will be. Yes, they will always be at ted.dev/talks. And as I mentioned before, they're living documentation, and especially if, right, here's that domain-driven design term, ubiquitous languages. If you're using terms from your domain, whatever domain that is, and some parts of your tests may not be the business domain, it may be the technical domain, right? I'm dealing with, storing stuff in a database, but there are technical terms there that we want to be consistent. And so using good names is always important, but reflecting those in the tests especially, I think is vital. And we want them to be comprehensive, right? Obviously code coverage can be useful as a map. Mutation testing is obviously better for things like that, but we want them to cover things. And so sometimes we're doing TDD, we need to add more tests than sort of the code might be telling us. And it helps with discipline. And so, of course, discipline is easier in groups, which is why I'm such a fan of ensemble or mob programming. It's much easier to say, oh, we really should do this. Whereas if you're on your own, you might just say, whatever. But in a group, that sort of, at least for me, raises my discipline. And so there are a bunch of principles that we can apply to tests, and Brett Schuchert and Tim Moninger obviously are the ones that wrote this down a while back and are my go-to. It was in a book called Agile in a Flash from the early, or I guess late 2000s. So I want them to be fast. To me, that means like 2 seconds. I want to be able to run 1,000 tests or 5,000 tests in 2 seconds. And there are multiple reasons for that. One is obviously if I'm doing test-driven development, I don't want to wait very long. But also I mentioned mutation testing. One thing that mutation testing does is requiring running of your tests a lot as it tries to mutate and tries to make your tests fail. And if your tests are slow, then you're going to be waiting a while with mutation testing. You want them to be isolated. You want them to be independent from one another. Not only that tests should not affect each other, but you also want them to be readable in isolation. I think this is key. And this is a different way of looking at code than regular production code. So Lana says mutation testing will always be slow even if your test suite is fast. I mean, it's slow is relative, right? Is it going to take me 15 minutes or is it going to take me 12 hours? I've seen mutation testing running against some Apache open source libraries, and it takes like 12 hours. Whereas I run mutation and I can go and have a cup of coffee and it's done when I come back. So I laugh at R because sometimes the word respectable comes into my mind for some reason. I don't know why they have to be. These tests have to be respectable, but repeatable, right? They basically, we need to be able to not be flaky. It's interesting that I have some rules that I talk about in terms of testable architecture and separation of I/O, and I think if you pay attention to those, you generally don't get flaky tests. But it happens. I've come into legacy code bases, and I've worked in code bases where you have flaky tests, and you want to figure that out. Self-validating, you don't want, right? I mean, I remember way back in some number of decades ago, I was writing code that would basically do something and then print something out on the screen. And then I would have to manually look, is that what I expected? That's great if you're doing something like in a one-off, but you don't want to do that for 1,000 tests. You don't want to have to inspect stuff manually. And so you want them to be basically tell you everything's cool or something's not quite right. And so that's something that I think we take for granted sometimes. But we used to have to look at things manually. However, there is an aspect of looking at output that I talk about a lot when I'm doing test-driven development, basically call your shot or predictive test-driven development, where you are looking for a specific thing to fail and it to fail in a very specific way, right? This should fail because it's going to give me a null because I haven't written the code yet. And if you get some, out of bounds exception, you're like, wait, what the heck? What's going on? And so there is that aspect, but we're talking about, when we're running the test suites, we want them to be self-validating. And timely, and we can look at timely in all sorts of ways. If you're doing test-driven development, they're by definition timely because you've written the test as you're writing the code. And so there are different ways of looking at that. And there are other things. Kent Beck has his test desiderata. I won't go through these. You can go read more about that. But similar ideas. What do we want? We want isolated. We want other things. We want structure and sensitive, and sometimes we have to do a little bit of work of that, and we'll look at that. But I love the last one, which is inspiring. There's just something about like, yeah, I mean, they should, that's that respectable, inspiring kind of thing. Like tests should make us happy. So there are different ways of talking about the structure of a test. There's a range actor search, sometimes called AAA, sometimes called 3A. I don't like it because I found that like the order doesn't matter when it does, and so sometimes people get confused. So I don't use a range actor cert. Given when then is there's been a resurgence of it for some reason that people are doing this more. But actually, in the event modeling, event sourcing, event modeling world, this is how people are defining basically the rules of a slice of behavior, right? As I mentioned before, given these events that have occurred in the past, when we do this command, then we expect these events to be output. And so that comes out really nice. I came across assemble, activate, assert, which was kind of fun, but also it has the problem of being 3As. I've read perhaps not the entire book, but by Gerard Mazar's The XUnit Test Patterns. I don't know if anybody's read the entire book cover to cover because it's 900 pages. Welcome. All right. You better, you go. But it's a great, I mean, it's really, if you have not come across that book, it is timeless and defines a lot of the terms we use today in terms of test doubles and other things. And so he uses setup, execute, verify, and teardown. I don't do a lot of teardown. And so I basically use SEA, so setup, execute, and then assert. Basically, what do we want? What do we observe? I wanted to use O here, but then it would be SEO, and that's just not good. So, and sometimes there is no setup. We sometimes see that there is no setup. That's sort of the execution. Often when we're doing creation of something, so we create an object and we maybe assert some properties around it. So a basic C test, right? We've got, so this is from one of my applications that I use to manage my ensembles. So here the test is when an ensemble is completed, we should be able to say that and ask it, are you completed? And it should say yes, true. So we've got our setup and we execute the command. And often we like spaces in between, right? And to make it really clear, like, this is the behavior right here that we're interested in. That's what we want to test. And here's another one. This one is interesting because I'm actually grabbing an enum. So there's not really much that's happening. I'm not like instantiating anything. I could have inlined it into here, but sometimes it's more clear to have it as a separate line of code. And yes, SCA works very well if you're flying into Seattle. And so again, we've got, setup. What's the sort of, we're creating the thing that we're going to execute against, right? That's what we're doing. And so then we execute, which is going to be some kind of command method. It may be, again, that the command we're doing is the creation of an object. And so here we've got, I just want to make sure that when we create a new ensemble object, it should not be canceled, right? That should not be its default state. And this is useful because later on, we're going to need to cancel it and assert that now it is canceled. But you can't do that before you've done the baseline, right? And this is the 0, 1, many or zombies, where you want to make sure that there's default state of objects when you create them. And you'd like to assert that base case so that when you later assert something else, you're not building on sand. You're building on a solid foundation that you're building up. And so there's no real setup. There's simply the execution, or you can consider this setup plus execution with the new. Same thing here. So our baseline for a new ensemble is it's not canceled and it's not completed. And we can then make those assumptions and no longer have to check those again. Sometimes it's convenient, especially in Java with method handles. We might just do the execution inside the assertion. There's no point in maybe having a separate variable. And so here we do our setup, which is we create it and actually push it into a different state, right? So our setup is not just creation. And I think one of the hardest parts of writing tests is pushing the thing you're going to check into the before state so you can do something and check the after state, right? That's all of what we do is push stuff into a state. And sometimes we're just testing against, we knew it up and it's in the right state. But often, especially as we start developing more code and as objects get more complex with more states and more ways that you can push it, and then more rules about how you can move it from state to state, that's where it can get really tricky. And so we'll see that sometimes your setup part can grow really long because of that. That's one reason why it can get really long. Others is it can have to do with infrastructure and other things that you have to deal with. But that are not state of the object, but sort of state of the surrounding system. So I like to, code smells are a thing. It's useful to think about and talk about and explore. And so there are test smells as well. One of the ones that I see a lot is hidden setup. Okay, so what's wrong with this test? Yeah, go ahead.
Yep. Why is there a bagel in there? Why is it an everything bagel? Why is there a cookie? Why is there a donut?
Yes. Why the heck do we have this as expected? If you can't explain why you're asserting something in that test, if you have to look elsewhere, to me, that is extra work that I don't want to do. Because is it some default of some object somewhere? Is it defined somewhere else? Is it going to change and I won't know about it? And the reverse is, if I change this, is it going to affect a bunch of tests? And so turns out there's some setup method, right? That sets this up. I don't like to do this. I like to basically fix it and inline the setup. Yeah. So as the manual says, like this extra cognitive load, like these things are already hard enough to read, especially if you're coming into something new or you just haven't looked at it in a month. Why make our lives more difficult? Yeah, and there's also the question of why doesn't the receipt include trailing zeros? I see that. So, side tangent, I see this all the time in production apps that I use from banks, where it's like, here, you've gotten $5, 5.2. Like, no, that is not how we format dollars in the United States. 5.20. That's what we do. Anything else is simply wrong. And I see this, but in bank apps, it just boggles my mind. That's one of my pet peeves. The other is don't ask for first name, ask for full name. But anyway, so the way we fix this, the easiest way is we just inline it. Right. And now it's clear why we expect the bagel with everything. And we might actually say, oh, actually, maybe there's something wrong. Where'd the garlic cream cheese go? Was that supposed to appear there? Or maybe that doesn't appear on the receipt at all? Who knows? Right. And you get these questions that come up because you can see what the setup is explicit and what the output is. So someone asked about copying and pasting setup code. We'll get there. It's like, yes, that's a problem. But I would much rather have this than this. I'd much rather have a certain amount of redundancy, maybe verbosity, than not being able to see this. The flip side is sometimes, and some languages make this easier with name parameters, and so maybe those languages aren't as important. And sometimes your IDE can highlight things, but it's like, unless you're super familiar with this ensemble objects constructor, what the heck is zone date time now mean? And then if you have to, again, go look or hit the proper shortcut in your IDE to show it. So let's fix that. Let's just give it a named variable. Oh, it's the ensemble start date and time. Okay, now that makes sense, right? And so again, like we want this to be as readable as possible and more information to basically help us not have to go elsewhere to look for information. When will Java get name parameters? Someday, maybe, who knows? But for now, this is what we'll do. And there are other ways to solve this, but like, just do that. And then, then it makes the test that much easier. So another smell, and this is a big one, and I fall prey to this all the time, is unclear assertion message. So if this test fails, this is here in the lower right is what you'd see. Great. Expecting true to be, but it was false. What, like, unless you, like, I know that when I'm running a bunch of tests and I see this, I'm like, that doesn't tell me anything. Maybe the test name is good enough, but even so, like I'm often, the way my IDE is set up, I'm often focused on this part over here, the output, and I see that and I'm like, oh, now I got to go look which test was failing, and then I got to go look at the source code. There are worse things in the world, but it'd be nice to fix that. And the Boolean checks are sort of the big one there. So we can fix that. In AssertJ, just add an as. Whatever tool you're using, add a description of that so that when it fails, we can say, oh, the ensemble should have been completed, but was not. And then I can almost ignore the rest of it. And so one of the nice things about doing TDD is you see the failures, right? If you don't do TDD and you write your tests after, hopefully you're not finding tests that are failing because you just wrote the code and now you're checking that it works. And so if you never see the test fail, then you're never going to know that maybe the test failure message is not as useful as it could be. And so the great thing about TDD is I actually have a step where if I I'm getting better at putting the as in up front, but I forget about it all the time. And so I'll see it fails, like, oh, all right, let me put in an as to describe it better. And that way, when it eventually, maybe fails at some future point, it'll be a lot clearer. Because even in TDD, it's like your context is in the current test you're doing, and so you may not feel, oh, that's fine. I know it was going to be true or false or whatever. But 30 minutes later, you're going to appreciate that message was there. Sometimes you have tests that are very similar. So this code comes from the online version of my TDD game that I'm working on. So there are hex tiles. There's the right code for tests. The predict tests will fail to compile. When you discard a card, you basically move to the next tile. So you don't move. You basically stay on the same tile. And these tests are the same. That might not be so bad. Right? Smells are not things that we must fix, right? They're not necessarily problems, but just like, is that okay? And so parameterize your tests. And there are various ways to do that. This one is using an enum source because these hex tiles are enums, and so it comes from there. And basically it's, remain on same tile when discard card. And so it applies to these two. In fact, they're actually, as I develop the game further, there'll be a couple of extra tiles that I'll go and add. And that makes it very easy. And when you run the test, if it fails, you will see that information. So again, like, even though we've got the parameterized test and it tells us we expected this, but we got that. Especially with parameterized tests, you might not notice what the test name is, or sometimes, like me, you've got really long test names that don't fit in the window. And so again, add a description. And in Java with JUnit, parameterized tests, you can incorporate the specific parameter that was included to have that in your output message. So as I mentioned, like, I'm lazy. I often fail to add this and then regret it later. So if you're running tests and it fails and you see not great messages, go and add it. Like, that's okay. One of the safest things in the world you could do is add a description, unless you write the description wrong, which sometimes I do with Booleans. Like a lot of us, sometimes I feel Boolean impaired. Many times I'm writing a Boolean expression and I'm just going to write it and let it fail or let it pass and see if it fails. Then I must have flipped the Boolean, and then I'll just flip the Boolean and then it'll pass. LLMs are also great at not adding messages because most of the code out there that it's trained on does not have them. You might give it instructions and maybe you'll get better odds of it adding it, but go and add them. So here's a test that has a bit of redundancy, a bit of like, do we really need 4 examples? So this actually is a test coming from a library called JStachio, which is a templating tool. Like, are these exercising useful options? Right. So we've got, 70, 14, and then two entries where they're 35. I'm like, do we really need all those? Is this exercising something? Are there some boundary conditions that we're not aware of? And no, here it's just testing that the template generates the text properly. So, like, don't do that. Unless there's a clear need where you have boundaries that you need to check. Okay, then check them. And they should be clear what those boundaries are. Which sometimes can be difficult. But figure out what the boundaries are and then do that, and then have tests that are testing at that boundary and making it clear. Otherwise, like, it's like, why did you need all these people? That doesn't test and exercise the template in any different way than just having 2. There's clearly more I'd clean up on this test, but that was enough. Yes, test person, right? That's great. Thanks. Appreciate it. It was a great name there. As I mentioned, there's more I do to clean up this test. And yeah, I won't go. Like you could spend a lot of time on some of these tests. So here we have from my Blackjack code base that I use in my training. And if you know anything about Blackjack, you know the rules around ace are a little finicky. Sometimes it's treated as a 1, sometimes it's treated as 11. And depending on the rest of the hand, that's how it figures out whether it's 1 or 11. So there are a couple of things I could do here. And one of them is like, what's important here, right? So one of the things that I focus on is what actually is important and what is just necessary. So any thoughts? What's kind of not important in the setup part of this test? If you know your Blackjack. What could we care less about? Yeah, the suit. The suit in Blackjack has no meaning. They could be clubs, they could be hearts, they could be diamonds, is completely irrelevant. The only thing that's important is the rank. That defines, because what are we testing here? We're testing that the hand value is, or score is calculated correctly. And so, yeah, I'll skip that. I'll come back if later. So what we can do is we can eliminate that work. We can eliminate some of that stuff. So let me go here and let's go to Blackjack and test. And so what we can do instead is refactor to a method. Oh my gosh, we're extracting a method in test code. What the heck? And this gives us a much more readable setup, right? So instead of this, which is like, okay, like there's more verbosity than just the suit. Like, I don't care that there's a list of card. I don't care that it's an array list. Like, that is noise. That takes away, like, you want to not bury the important stuff, right? The only thing that matters is I want a hand that has an ace and a 9. And so I extract to a method, so-called create hand. I'm using a term from the domain, and ace and 5. Or ace and 10, or ace 8 and 3, right? Very clear, as little extraneous as you can get away with Java. Some people might say, oh, use var. It's like, okay, let's not go there. And so that's what we want, right? And so you extract method, easy. And then this is where you start climbing that ladder or those stairs is, oh, I have other tests that need this. Let me put it into a factory class. Oh, I have lots of variations, and we'll get to there. And so, in fact, one other thing is when I extracted the method, even in here, I sort of advertise the suit doesn't matter. This is just a dummy. Sometimes I'll use dummy, sometimes I'll use irrelevant or don't care, but gets the idea across that even here in this out of the way method, I'm indicating that it doesn't matter. And so I remember learning about evident data many years ago when I was first learning TDD, and it's in Kent Beck's book TDD by Example in chapter 25. And magic numbers, like, it's funny, like early on in my career is like, oh no, you don't want literals, right? You don't want numbers in your code, like that's bad. It's like, is it really? Now in production code, even there are times when it's like, and this is not specifically about tests, but sort of about like this 21 here. That's fine. Like, what else would you do with it? Extract it to a constant called 21? How is that helpful? upper boundary for hand. I mean, come on. And so like my tendency is not to try and turn these into constants, but to nest them in a method that makes sense and uses them in a specific context. Because if you're just extracting it, like I've seen this, it's like, why did you extract this number and then just call it the name is the number, like 21? Like that serves no purpose. There are times when it does, like if you have something like, max cache size, then you want, 1,000 or whatever it is, and you don't care that it's 1,000 because actually it might change. But for 21, that's not going to change unless the rules of the game change, and then you've got something totally different. But in tests, and so even in tests, we want more information. Like we want not just is equal to 21, but like where'd the 21 come from? Like I have two things here and I have only one number here. But down here, I can associate these two parameters with the expectation. Now, there are limits to this. You don't want to do heavy calculations in your assertions because now you're like recreating the production code and now you're actually making it hard to read. But this kind of thing is useful because you can very quickly associate, oh, here the aces counted as 11 because that's important. The 10 needs to be there, but that the aces counted as 11 and it makes that obvious. So you can sort of see, like, as you refactor the code, as you refactor your setup, mostly setup, but sometimes assertions and you start to get to the point where, okay, now I've got this factory method and it's got 10, 12, 15 variations. Well, the typical solution we do in production code for telescoping constructors or other kinds of things is test data builders. Now, if you ever studied the Gang of Four builder pattern, this is not that. Even though they are called builders, they are not these kinds of builders. Which, the pedantic part of my brain is like, but I'm okay with it. I first learned about test data builders and call it that from early 2000s when I was working at Google. And basically it was popularized by Joshua Block, and that's why it's sometimes called the block builder pattern. He wrote in a book called Effective Java, and in there he talks about the telescoping constructor problem where it's like, oh, I have this one. And again, this is a Java specific thing because you don't have named parameters, but there are lots of other reasons why you want to do this kind of pattern. And essentially it's a fluent or chained API. So here we've got, and this actually comes from his book. We've got these nutrition facts, and we create this private constructor that takes a builder, and then we create the actual builder that has ways of specifying optionally, right? I think that's important. And so in Java, there is this evil virus called Lombok. And it's terrible for many reasons. And one of the things it supports is the ability for it to generate builders. I don't get it. I just don't understand it because it generates a full builder without any idea of which ones might be optional. How would you set those? Better naming, things like that. And it's just don't use the, just say no to Lombok. I was at Java One last week and they do an ending keynote with all the architects on stage, and Lombok came up and they said, don't. So here on the builder on the right side, we can basically create this Fluent API by always returning the thing itself. And there is an art to this. So AssertJ, if you want to see the ultimate in the state of the art of, oh my God, there's so much generics here, is code. Take a look at the AssertJ source code because it does this to a much greater degree that hurts my brain. But here it's pretty straightforward, right? We basically continue to return the object so we can call more methods on it. Sometimes that's not sufficient. And AssertJ goes one way, but we'll look at a different way to do some customization in a bit. And so here's how basically we use it. So we're creating a thing, Coca-Cola, We create the builder. So one of the nice things about the constructor, the builder, is you can force people, right? Again, what I love is the idea of make it hard to make mistakes, right? The pit of success, right? We wanted to easily create things that so people can't accidentally misconfigure things. And so here we're saying, look, you want to specify these nutrition facts, serving size and servings is required. It makes no sense to create one of these without it. Well, we put it in the builder, right? So when we construct the builder, those are the parameters. You can't create a builder until you specify those things. And of course, you could do validation. Validation inside of builders is very useful. I can't tell you how often I put in validation and then violated it. And it's like, oh boy, thank goodness that was there. And so here we basically create the builder, give it some values, and then we can call these. And one of the nice things about the builder is you don't have to call all of them. There might be good defaults. In fact, that's the entire, for me, one of the main reasons is you have all these variations. Sometimes you want this, sometimes you want that. And being able to specify that without having to specify a bunch of things that you don't care about, right? So only specifying things you care about is what we want. Side benefit, and I remember this early on mattered a lot. Maybe it doesn't matter as much anymore. But diffs are really easy when you format your stuff like this. It's like, oh, look, we added a sodium. We didn't have that before. Whereas if it was just a parameter to some method, it would be harder to see. Yeah, so the nutrition facts constructor that takes the builder is private, and then you can use a method to basically say, now you can ask the builder to then build it, and then it does the building. And there are a variety of ways to create these, but this is sort of a straightforward way to do it. Now, where test data builders sometimes make life a little bit difficult is if you have more than just a single object that you're configuring. You know, you might have an aggregate that has a bunch of other entities and value objects, or you want to have some different ways to do it. And there are ways to sort of return a different interface or a different class that's sort of a sub builder for something, but that can get really difficult when it's like, how do I sort of pop back out? Like I finished modifying this entity, this sub entity, and now I want to pop back out, and it gets really difficult. So something that was inspired by Spring Boot, and in Spring Boot, you have to do a lot of configuration. And so they have what's called a customizer. So what we do here, so what does it look like to use it? So here, this is coming from Jitter Ticket, my event sourcing concert ticketing system example code. And so here, one of the things, again, like I have a builder for make events because I make events often, right? It's event sourcing, you're making events all over the place in your tests. And so I want to make events with concert scheduled. Concert schedules is a specific concrete event. But I want to customize the concert that it's going to schedule a little bit. And in fact, not just customize it, but I also want another event that has to be connected to concert. So I need a concert scheduled event, so it's scheduled, and I know what the ticket price is because that's what I care about for this test. And I want to sell some tickets, which is actually a separate event that gets generated. So I want two events out of this, but there's a connection here. So I kind of think of as this tickets sold as being sort of a sub thing of the concert scheduled. And so in Java, lambdas are the answer. And notice that I'm only specifying what I care about. The rest of the test basically just does an assert 6 times 35. Is that the answer? And sometimes I want to configure different parts, right? Here, I care about the show date and time. When does the concert actually happen? And here I'm generating 2 of them. So I want 2 concert scheduled events in my stream. And here's another one where I generate a different event, right? So we've scheduled the concert, and then I want this ticket sales stopped event, again, because that ticket sales stopped is associated with the concert. And you can see, like, if you had to write this with a regular builder, it would be really difficult. You'd have to basically build this thing, get the value out, figure out what the ID of this concert is, and then send it into the other event. And again, I want to get rid of that stuff. And so I won't go through this code. You can go look at it. But this is basically using the customizer. And in Java, it basically uses a function so that you can pass in that lambda. And then it just checks, do you call certain things? And this can get really complicated, and there are various ways of writing this. But this idea can be really useful when you start getting into these nested configuration types of things. So Stephen asks about, do I have builder with a prod code or with a test code? It depends. Most of the time I'm using these builders for test purposes. It is actually quite rare in the kinds of code I'm developing that I use builders in my production code, because I don't generally create objects that are of so many varying kinds of configuration. Especially with event sourcing, I don't create objects much at all like that. And so generally it's in the test code, and that's why they're test data builders. Trying to think of, there's a couple of instances where I'll sometimes use it in production code, but now there is something about production versus test code, but I'll get to that later. This is a true statement. Assertions are better with AssertJ. I don't understand, like, unless you're really do not like pulling in libraries that only appear in your tests and it will never appear in your production files. Like, why are you just using raw JUnit? Stop. What is the order of assert equals? I have no idea to this day. So I have an entire talk plus many hours of stuff just on AssertJ. One of the things I like to say is make sure you brush your teeth after using AssertJ, because it is just full of syntactic sugar, loaded with sugar, loaded with literally hundreds of ways to do things. Because that's its purpose, right? We want to make it really clear, what are we doing? And so here's just like, this I do a fair amount, is you should be asserting against exceptions, right? Tests are not just for the happy path. You want to make sure that exceptions are thrown in specific cases. And you probably want to make sure that those tests are throwing exceptions with specific messages as well, especially if those messages end up in a log or on a screen somewhere. So you want to write tests for that. And there are various ways to do it. There are always more extensions. So the Spring framework is a big user of AssertJ and has contributed stuff back. And so we see that here. Since we often assert in Java on a legal argument exception, we have a dedicated method for it. But that's not the only way, right? You could do it this way. You could do it this way. So if you can't figure out at least 3 ways to do something in AssertJ, you're not looking hard enough. And let me tell you, I've been doing this for a while, and sometimes we'll be like, oh, like I'll be, streaming, and Sweegie or Daniel Ranner will say, do this. And I'm like, oh, of course I could do that. Right, so we can say assert that thrown by and then execute the code. Expression. I do a lot of custom exceptions. So this one is probably the one I use the most, because it's not always a legal argument exception. Sometimes it's user not found, or even concert already canceled, or scheduling conflict exception, things like that. So if I actually even have like I think one of the places where AssertJ really shines, besides making it really clear to do stuff, is collections. Lots of stuff, especially in Java, is with collections, and you can do all sorts of crazy stuff. Look in my various code bases that I'll share for examples of that. So we'd like to get closer to the domain, though. We'd like to have the test more readable and used, so we did a little bit of that with our setup, but the assertions should get some of that love too. So in Blackjack, one of the important things is there's this idea of cards that are face up or face down, right? When you first start, the dealer's card is one of the dealer's cards, what's called a whole card, is face down. whole as in H-O-L-E, not W-H-O-L-E. The whole card is face down because otherwise, what's the point of the game? Blackjack, you play against the dealer. You do not play against the other players, a common misconception. And so figuring out if the card is face up or face down is important, and therefore we'd like to test it. So this is fine. We could do this, right? We've got our stub deck builder. So we build a deck with specific ways of doing this. If you want to see some nice builders, go to the Blackjack source code, right? So here we say, I want to create a deck where a player is going to get these ranks and then build it where the dealer doesn't draw any cards. Notice it's dealer does not draw cards. I don't care what those cards are. I just want the situation of the dealer, because there are rules around the dealer, they're automatable, would not draw cards. And if you know the rule, it's basically if they have 17 or over, I don't care what they are. It doesn't matter. I just want to make sure they don't draw. And then create one player game, place bets, initial deal, right? I need to fast forward the game through its, shuffling of the cards, dealing the cards, placing the bets. And let me tell you, and those who are in the ensemble for this know what I'm talking about, is when we added place bets, oh my gosh, we had to change a bunch of code because there's a bunch of code that went straight to dealing the cards. But if you place bets, you can't do that. You have to place the bets first. And so all the places in the code where we were just calling directly to initial deal, we had to change all that. And so we put it into our factory method that basically did that for us. And so what we're testing is that when the player stands, the dealer's card is no longer face down. Not terrible, right? I mean, you could read it. Is face down, you could say, oh, maybe we should have an is face up method. That might be a little bit better. But there's stuff that's like all match. What does that do again? And right. But I think we can do better than this. So we could create a predicate, and then we could put that predicate somewhere to reuse across things. That basically translates the is face down to basically face up. So now it's like assert that game dealer hand cards all match the face up card predicate. A little bit better, especially for those of us Boolean impaired. I think we can do better. We can extract it to, hey, why not? We can extract methods. It's this code, so we can extract methods to a separate method, assert all dealer cards face up. And then basically now we have what I want. That might be where we stop. However, we can write custom assertions. Look at that, right? Assert that the game, the dealer hand, all cards are face up. And so this then becomes much more usable, but these are actually AssertJ assertions that we've customized. Is there a none match? Of course there's a none match. The answer to every question of does AssertJ have X is that yes, it does. As I said, it's got a lot of sugar in it. And so now we could say assert that dealer hand, and then there's all sorts of assertions on the dealer hand, and those assertions might be different than on the player hand. In player, there is no face up or face down. Who the heck cares? Because they're always face up. And so again, one of the nice things you get is if I hit dot, I get this autocomplete of possibilities that make sense in that context. And so that's much better than this. This is, I might stop here if I'm only do this a few times, but eventually I might really want this custom assertion. So when we extract methods in Java, one of the problems we get is I need multiple pieces to do something. Right? If I extract to create this game and I only call something on game, then this is fine. But what if I needed something else, right? Like, what if I wanted to extract this entire thing to a method, but I need both the deck and the game? What then? What do I do then? In Java, you can't return multiple values. However, you can, using IntelliJ, if you try to extract basically a chunk of code, and you then access multiple pieces later on, it will extract a record for you. And so I often call this record a fixture. It has the pieces that I need within my test. And so then all of this setup stuff, which is necessary for the test, is hidden, and I get a fixture, and I can access the customer and constant store and things like that. And that's really nice, because now when I write my tests, and I can just have this fixture. Now, there's something that I learned from James Shore about, well, maybe you put your sort of creation of this thing in your production code. Now, that's, again, a whole nother presentation. James Shore talks about it and regards to nullable infrastructure and things like that. And so I did this the other day, and I was like, I like this. I had been doing it for other things, and where it really shines is where you have these nested, where you only want certain things to override in this sort of, there are a bunch of dependencies. And so this is I have in the schedule concert controller at the front end for scheduling concerts. For tests, I'm going to need an in-memory store because I don't want to use the database. I need a memory persistence for the projection, blah, 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 right? And so all of this is in the production code. Because if I change some of these things like the constructor, again, I've encapsulated this inside of where things are likely going to change, right? Refactorings get triggered often by changes in production code. And so all this idea of extracting method, data builders, all these kinds of things, that is the protection against, oh my God, I have to refactor this, and now I've got to change 300 tests. Probably too late, although you can use certain tools, not AI. Structural replace in IntelliJ is very powerful. And you can do some very nice things with that don't require AI, that are deterministic. And there are other mechanisms you could even use in like an open rewrite, those kinds of things. You don't have to go to LLMs. So fixture created inside the production code. That's nice. Okay. And so the last thing is when we organize our tests, at least in Java, we can have JUnit supports this idea of nested classes. And so this allows you to organize, so I have this test that tests this concert sales projection, and mostly testing around because it's the infrastructure part. So it's doing persistence and catch-ups, subscription, all this kind of stuff. And it's a lot of tests. Maybe not a lot of tests. A lot is a bunch of tests. But if you organize them as nested, then what happens is when you look at the structure of the program, Command F12 for those of you on Mac, you basically see, oh, here are all the different sort of subsections, right? Here's all the stuff dealing with projection newly created, and then all the tests dealing with that, persisted, all the projected summaries, and this test dealing with that. In addition, IntelliJ supports this idea of regions, which I use for both tests. So here we can see, oh, I've split out and separated the fixture code and my test doubles that are needed for this code. And so you can very easily navigate the tests without seeing 35 tests, and maybe some of them start with the same letters, and so they're organized that way. But no, just put them in nested classes. And the region stuff is great also for your production code. So customer in an event source system is likely going to have a way to create it, a way to apply events, and then commands and queries. And again, it makes it very easy to get an overview of the code. So, right, the ultimate difference between tests and production code is tests are specific. They're examples. They guide our development, or hopefully guide our development. And hopefully code gets more general, sometimes more compact as we go. And so duplication, literals, even though I'm okay with some literals in production code, we want those in tests. Duplication, right? How much duplication we want? I err towards a little bit more duplication than perhaps I used to, but still we look for abstractions that eliminate some duplication, so code not as much. So these aren't as strong as like totally green and totally red. It's we do more of this and allow more for this in our tests than in our code, right? So abstractions, we want those in tests, but they're different kinds of abstractions. They're more like, how do we get here? What's the situation we're creating? What are the assertions? And of course, we want abstractions in our code. All right. So tests are code too. Don't forget, that means they could use some refactoring love. Sometimes you'll remember some of the stuff up front, you'll just write them. Other times you need to go and refactor. Like anything else, you refactor when you start seeing, I've done this for the third time, let me go refactor. But don't go right to builders. Start with refactor to a method, then put those methods in a common place that other tests can access, and then maybe see, am I configuring them differently? I've got a lot of variety. Let me create a builder, and then maybe go for the customization and keep going down that road. And also don't forget about your assertions. Raise the level of abstraction from a domain standpoint on those as well. So any questions or any questions that I missed along the way?
First, I love that. That was really enjoyable. And I love that I continually learn things. So thank you. Um, a quick question about the regions.
Mhm.
Is that in IntelliJ you said? Is that the
Yes.
same as like the regions that are in Visual Studio for C Sharp, where you can sort of create a block of code?
There's no semantic or syntactic, like it is purely a display
Okay.
thing.
Yeah, so
Yeah.
same sort of thing, I believe that in C Sharp, I believe you can also um, like choose compilability in terms of like this region will compile and this won't, or depending on, which is terrible. You shouldn't use it. But okay, in this case, it's just a collapsible section.
Yeah.
Okay.
It's basically a named collapsible section.
Excellent.
Yeah. And so when we look at it, we can see, oh, what are my queries? Oh, these are all my queries. What are my commands? Oh, these are all my commands. But it's purely an IntelliJ thing. Otherwise, it's basically just a comment. But really handy. I picked this. I use it occasionally before, but I picked up or repicked up from Donald Robb, who created the Eclipse collections, and it's used all over the place because you can imagine it's a new set of collection classes. Like how many methods are going to be in like a list? Oh my god, but they're going to be some associated with initial creation. They're going to be some associated with adding, removing, all sorts of varieties, searching, and things like that. And so when I tend to like smaller classes, but sometimes you just want to and I find it really useful because there's a common pattern for me in almost all of my objects where there's commands and queries. But further in event sourcing, there's also event application and other things.
Sorry, I have another question, and I don't, please, everybody else jump in if you have stuff.
Yes.
How hard is it? I think I've tried, but I haven't in a while. Like, how hard is it to sort of extend the AssertJ stuff?
There's a variety of ways to do it, and they're pretty straightforward. You can go with you can actually use the code generator, but I find that generates a bunch of classes that you may not need. They're kind of three levels. That's kind of like, let's do it the most AssertJ-like way of doing it. But there are some variations. So if we look at Blackjack and we look at hand assert, I mean, there's not a lot of code. It's basically you extend some abstract assertion depending on what you're doing. This one is actually generated but you can just see like the actual assertion. So we got our hand assert. What is it doing? So we just define methods, and then you might do something. Okay, then we've got a card assert, and there's some generic stuff that you have to do, but it's not that hard. And there's some easier ways that don't require this many abstract base classes and things like that.
Excellent.
I have one more question, Ted.
Yes.
So maybe do you have, I saw that you were using the builder implementation and at the test level, and that's great. I sometimes ask myself, when's the perfect time to write that builder? When is it worth putting all those effort into it? Do you have any?
Yeah, my heuristic is like if I'm like around 4 or 5 methods that are kind of creating the same thing. So I've got concert factory. This is a little bit past the point where I'd convert to builders. So here I've got create a concert with show date time of. Oh wait, create one with show and door time of. No, create one that takes the concert ID and show it. Like you can see, like even here, there's 3 of them that are doing the same thing slightly differently. That to me is this very strong signal. I probably could go to builders here. And now but this is all about creating concerts, and I've got like 10 different ways of doing it. This is beyond. So for me, about 5 to 7 of these where I've got this parameter, not this parameter. And again, this is because languages like Java don't have optional parameters. If you do have optional parameters, I still think it's easier to read, and you get this better configuration ability with builders. But for me, it's about 5 to 7. Like I'm human, I don't always do it. And so this one actually is on my list to convert to a builder.
Thanks.
There's a question in the chat that I'm going to paraphrase a little, right? When we refactor our production code, we use our tests to ensure that we haven't broken anything and ensure that trust. But when we refactor our tests, how do we continue to ensure that the tests are still correct and that we haven't sort of changed them or broken them?
Don't refactor unless you're in the green.
Okay.
Right? I mean, if your tests currently pass and you refactor your tests and the tests don't pass, you have done something wrong. If they continue to pass, right? And what's really interesting, because you're now using the code that is fixed and not changing and works at least as far as the tests are expecting. And so now you can use that to say, let me refactor my tests. And if they continue to pass, then I know that they're still testing the same thing. I mean, there's no 100% guarantees in anything, but that is, if your test covers it, it will doesn't, since a lot of it's usually when moving to builders. So that's a really good question for builders, because often when I'm just extracting method or so on, those are reliable. Those almost never break anything. But moving to builders, now you're designing something new. And sometimes I will say, this builder is complex enough, I'm going to test drive this builder. You want to do that though when you know how it's going to be used. And sometimes, right, this is where it's like TDD is helping you design the thing. And so you're going to use that to then say, oh, I need to test this builder, especially if it's going to have any of these nested customizers and things like that. So you might basically take a step aside and say, let me go, I know I need a builder. I kind of know what shape it's going to be. Let me test drive the builder. And then replace it into your code, which should already be passing. And so it should be a one-to-one, right, transparent. And now I'm using a builder before I was using direct code. And so that is your final test that now I've installed this new thing, the builder, and everything works. And for me, green, if I'm doing something like a builder, I want to make sure I'm really in the green. So I have a term that I call tests are failing as predicted, and I call that olive. Right, like on olive, it's green, but it has a little red pimento. So it's green in the sense that it's doing the right thing and it's doing it the way I expect it. I just maybe haven't implemented something yet. And so for me, I allow myself some amount of refactoring in that state because it's greenish. But if you've got if you're doing anything more than just like I'm going to extract this into a fixture or that kind of thing, get in the full green. So nullable infrastructure, basically it's instead of putting these creations of the setup part, especially often associated with test doubles, don't leave that in your test code, put it directly into the production code. And so here, let's go to schedule concert controller. And so here we've got our create for tests, which normally you'd see in test code. And people I was this way too. People are gonna be like, there's test code in production code. You know what? That's not a problem. Where it's a problem is you have some if statement in your production code that says, if in test mode, do X. Do not do that. Do not do that. Extract it to a strategy, then mock test double the strategy, but don't do that. This though is setup, right? So almost all of any kind of test-like code that it will have in production code is all about setup, right? Because there's a bunch of things that this controller needs. Eventually it needs, in order to create the controller, it needs this thing, which needs this thing, which then needs this thing, right? And so you let the code decide, and then there can be variations of this. And then I can return the things that the test needs in order to do its assertions.
It was very unnerving to hear that, but I think you're right. The issue isn't adding test code to the production code. The issue is changing the production code to make something that's private public so that I can test it, or I'm adding some sort of check
Visible
to
for
say,
testing, yeah.
yeah, if environment is test, whatever. And then like even create for test, I'm not sure that would be the name that I would put there. I would, make it more like create a default or something to that effect. But it reminded me of David Scott Bernstein gave a great talk, and we don't usually record his, but on sort of how to instantiate an object and let the object do the instantiation for you. So he talked about having static constructors and builders within each object. So instead of saying new schedule concert, you would just say schedule concert on date and whatever, and then it knows, and you don't have to actually new up stuff. And this sort of reminds me of that a lot.
Yep. Yep. So I would not do that for events, because events are basically just data carriers. But you can see right here, to me, like this idea of unnamed constructors, like I agree. It's okay for some things, but it's nice to say, well, how do you kick off a concert in existence? You schedule it. That's how it comes into existence in this domain. And so you can't call the constructor, you call schedule. It calls the constructor, and that's another way of. And IntelliJ has some great tooling for convert this constructor to a factory method, or to and that's really useful again to encapsulate this stuff because one of the things about constructors is that they're very hard to work with from an automated refactoring point of view. They're there's just, you want to do things with them, and it's just like, I can't do it because it's a constructor. You turn it into a static method, and now you have the freedom that you have with all other methods. And I think that's yet another reason to do it. But I find named constructors, basically these kinds of static things, to be much more readable. And often what people will counter with is like, oh, but now I have this method create for test that shouldn't be called in production. What happens if somebody calls it? It's like, well, don't do that. Doc, it hurts when I do this. Don't do that. On the other hand, it's like, what if people don't know and they accidentally do it? Well, what I have is annotations for test only. And then I use a tool like ArcUnit that makes sure that only test code calls this method. Because Java doesn't have a good way, to say only these packages. That has some stuff, but not as precise as what I want. Use those tools, right? Those tests basically have enforcement for like, this method should only be called by the repository because it's the only one that knows about this way of extracting the snapshot flow, right? Use those tools when the language doesn't help you, and there's similar tools in other languages.
Just to clarify, I was talking in the chat saying that most of the things you were mentioning were related to IntelliJ with Java, because most of the things like go to a constructor, alt enter, or whatever shortcut you want to use, depending on the operating system you have, work mainly with Java. But if you use it, for instance, in C#, most of the shortcuts don't even work, and TypeScript either, and so on, and even the shortcuts change. So be aware, because we were having that conversation in the chat, and I was like, maybe say it. With Java works just fine, most of them, but with other languages, it's not the same.
Yeah, I mean, other languages don't have the support because of the way they are, or just the IDEs are, like JavaScript is really hard. TypeScript has more of that because of the static typing. It's one of the reasons I'm still using Java is because like the tooling is so awesome. I would have left Java long ago if the tooling of the automated refactorings had not been there. But it IntelliJ and IntelliJ idea is like, covers other languages, and it is getting better, and they are adding more refactorings to other languages. But yeah, sometimes you will have to, like, it'd be nice to have an automated refactoring, but sometimes you will have to do it manually. And that does change things a little bit in terms of when I do things. So if I'm working in a language where I know the automated refactorings are not going to be available, I might do stuff earlier. I might go to data builders earlier. I might go to better constructors if the language has need for that static method kind of things earlier, because I get lazy because it's like, I know I can refactor this later, but if I know it's going to be really annoying to refactor later, then I'm gonna do it earlier.
Excellent. I think this is a great time for me to stop the recording and we can continue to have a discussion. But I want to say thank you again, Ted. This is really fabulous. We'll post this online soon. And right, you can go to ted.dev, which is the awesomest thing ever. I love the fact that you're able to get that domain.
So lucky.
Yeah, and find all his stuff. And I'm assuming it also talks about where you're going to be in the future.
Yes.
All
Yes.
right. And we really enjoy having you. So thank you very much.
Thank you.